How to start with unit tests or even test-driven development when you're working in a database legacy application in Delphi. My name is Kees and in this video I want to explain you how we approach this and how we get started with these kind of projects. I work for GDK Software. We are specialized in Delphi, so we deliver capacity and Delphi expertise to our customers. You can see my LinkedIn profile link in the presentation, and from Marco, my colleague as well. We work in 3 offices, one in the Netherlands, one in the UK and one in Brazil. And you also see a link to the Delphi Hero mailing list, which I recommend you to subscribe to. So this video and this presentation is about test-driven development. And test-driven development is the approach, so how you develop. So you work based on tests, and mainly you use unit tests to write your tests in. It's also partly about integration tests, because officially when you approach the database in your test, it's an integration test. But if you have a legacy Delphi database application, you can't without the integration, at least at the start of the project. Because otherwise you can't run your existing code, and that's what you need to set it up and to ensure that your existing code base keeps running and keeps working well. Unit tests are also able to run in automated tests, because you can run them command line, for example. Unit tests and test-driven development is not especially about, for example, performance tests. Although maybe you can do something with it, it's not meant for that. Even it's not meant for UI tests, functional tests, regression tests, or whatever you can do. Maybe it's part of it, but it's not what it is. Test-driven development and unit tests are for the developer and makes the way the developer works different. So what is test-driven development? Very simple. First the test, then the code. Or from another perspective, you don't write code without having a test for it. So ultimately all your code is covered by tests. And test-driven, yeah, the word is saying itself, is driven by tests, your developments. So why should you do test-driven development? There are several reasons for that. First of all, it changes your approach as a developer. Of course, you always look at the requirements, but very often you quickly start coding and thinking, oh, I understand it, and not especially thinking about all the situations which can happen with this requirement. So when you start writing a test first, then you have to think about, okay, what do I test, and how can I test in such a way that the requirement, that I really can test that the requirement is done by the end of the test. So you get a completely different focus, which is, I think, a better focus. Yeah, and another great advantage, of course, is that your code is continuously validated. So even if you refactor or you change things, and every time you run the test and you know, okay, everything I covered with tests is fine. Because I think every one of us knows the situations like you change the thing in that module, but another module doesn't work anymore because of that change, and you didn't realize. So tests help you with continuous validation of your software. It's also very often simpler and easier to develop with unit tests, and especially for bug fixing, but also building new parts. Because most of the time you test and debug by running your application, and legacy database applications very often are starting slowly. You have to click multiple paths to go to the place you want to test or debug, or and so unit testing you can use by using parameters, for example, run only the test you're working on, and you only go through the code you want to test. So running a unit test is by far quicker and faster than starting up your application every time and clicking every time. So it's easier to develop and easier to bug fix as well. And I'm assured it improves the code quality, because it's not in legacy applications, very often the code is very tightly coupled. And if you want to make it testable, you have to split it more. So that makes it more insightful, it's better reusable, it's better maintainable. There are a lot of things to say about that. It's not, of course, that it goes automatically, but at the end, I think you end up with better code quality. So enough reasons to start with test-driven development. So how does it work practically? Of course, via unit testing. You start with writing a failing test or writing a test. You write the minimal code to get the test passing, and then eventually you refactor the code if you want. And that's nice, because then you have a working test. So if you refactor, you immediately see if the code works or not. There's maybe one slightly different situation when you not start with writing a failing test, and that's for existing code. So if you write a test for your existing code base, you describe a situation and you expect the situation to be passing the test. And that's the base setup, so that you can start refactoring the code. But mainly when you write new tests, you start with a failing test and then you write the implementation. It's the same for bug fixing. So somebody reports a bug in a certain situation, you first write a test to reproduce the bug, and then you write implementation for that. But how do you write a good test? You can start with using the GWT approach, which is saying, okay, given the situation, when this or that, then I expect this outcome. It's also a good way to describe your procedure names for testing. And within the test, you can use the AAA approach. First, arrange everything you need for the test, then act, so you execute the code you want to test, and then you assert everything you want for that test. A good test also is testing one test situation per test. So if you have logic in your test, it mainly means that you need another test. It's another test situation. The best you can start with testing the ideal path. So don't think too much about exceptions or borders or limitations. Just go, okay, if everything goes fine, the data is delivered fine, etc. What's then the ideal path to fulfill this requirement? That's the easiest method to start with tests. And after that, you can expand your tests based on limitations, unauthorized situations, exceptions, or there is existing code, maybe you want to cover more of the code. How does that work in practice? I think the first important point is that it's a culture change, because when you work alone, it's more maybe mindset as well. But if you especially work in a team of multiple developers, you have to agree about this and say, okay, we're so convinced about the advantages of unit testing that we want to do it for all our code changes if possible, and it's possible. But realize it's a culture change, it's not going from itself, because you're so used to start directly coding and thinking, this is just a little change, why should I do it with a test? Because then your code is covered and it's tested over and over again. That's the reason. So it's a culture change, it's a mindset change. So remove the barriers, remove everything, make it easy to start, and then just start. Do it. Make your tests and integrate it with your work. So don't start a separate project to say, let's start a project to cover all our existing code with unit tests or a lot of code. Now just integrate it in your daily work. So pick up a story, read the requirements, make tests, and then make code. So that's, I think, how it works in practice. Let's go over to do some demo in the code. First, I want to show you how to install DUnitX, and then how easily you can create a new unit test project in your Delphi environment. And I defined some simple tests to show you how it works. Go to Tools, Manage Platforms to get the Delphi installer. Go to the additional options, and there you've got the checkbox, unit testing frameworks. Click on Apply, and you've got DUnitX in your Delphi IDE. There you go to File, and then New, and then DUnitX project to add a new unit test project for your application. I already did it. I did it for CMist. As you can see, CMist is a large database application legacy. So that's the application I want to use in this video. And I've written a little demo to start with to show you some simple examples. So here you've got a calculate function with an input parameter. I only add one to the parameter, and it may not be more than 99, otherwise you get an exception. So this is basically the test. You see the DUnitX test framework on top of it. It's containing everything you need for unit testing. And then it starts with the attribute test fixture, which means this is a class containing tests. Then you have the test attribute above your procedures, which are the tests that will be running. Then you've got the test cases you can use in combination with parameters, because the second parameter of a test case contains all the values for the parameters of the procedure. So 1 in this case is input and 2 is expected. So when we go to the tests, you see the word assert. Assert contains all the methods you need to test your output. So R equal is very often used, and at when input exceeds maximum test, you see assert will raise as well. So I use test cases here to show you that you easily can add several tests with different inputs. So I test for the positive, the negative, and the maximum value in the same way, just running the same calculation, and test if this is true or not. The will raise exception is a little bit different because you need an anonymous procedure. You put your execute, your act in there, and it will calculate, and you try to find out if the exact exception is raised. So let's see how that works. Okay, all the tests are passing. If we have our unit test project running, now we can link it to our existing Delphi project and make it available for unit testing. So the most easy option to do that is use the search path in the project options, which is the most easy way to go, because otherwise you have to add a lot of files most of the time. So after that, I show you some tests I created for a chunk of code not using a database. So here you see a torderlines class we already built in the existing software, and I found two functions which has nothing to do with the database and just calculating the things. So I made some tests to test these two functions. So here you can see the tests. I added a category as well, because then it's easier to run specific this tests, and I will show you later how to do it via the parameters of the application. And I defined two tests into it, the VAT without order lines and the net value with order lines. So for the VAT without order lines, I just create the order lines object you saw, and then I run the get accumulated VAT function, which don't have a VAT, so the VAT amount should be 0. So I test assert equal 0 VAT amount. For the other procedure, I create the order lines again, and I create two order lines into it. I assigned some values, calculated the accumulated net value, and the net amount should be equal to the given amount you see there. So now I pass the order lines into the parameters of the application with the keyword include, and then it's only running these two unit tests and skip the others, as you can see. And I'll remove the parameters and run it again. And then we see 6 test passes because the original 4 are now included as well. So every test is running. Our unit test project is created, is linked to our application. Now we want to have the database access like in the normal Delphi application. So just use the same initialization code as your Delphi project does, because then the code is behaving the same as your application. Sometimes it's necessary to use a compiler directive to skip some code, even especially when it erases some windows. You have to fill in authorization or whatever. But mainly you can use the same initialization code. So I created a simple test to see if my database connection works. So I added a new unit for this simple test I created. As you see here, it's just looking to open a users table from the backend data module, which is the main module in CMist. And once I can do that without raising an exception, I've got a running database connection. So here you see the DM backend created. It's just a global variable as the same as in the application. So for me, it's just creating a data module. For you, it can, of course, be more work to initialize the right things. But so when I run the unit tests, the test is passing as well. The only thing I had to do here was using a compiler directive to get rid of a splash screen. So I did it with compiler directives and later on partly with properties in the code. As a next step, we want to add a test for existing code using the database, because that's very often the case in a large legacy database application. So search for a class with relative simple and straightforward database action so that you can easily start testing it. And initialize step by step what you need. So don't put all the data modules in your unit test project when you don't need them at a time. When you run database tests, you want to be sure they run over and over again and passing each time. That means that if you add or change things to the database, you have to roll them back after your tests. So that's where transactions are coming in. And I configured the start transaction, the rollback transaction, so that after a test, nothing is left in the database. And I use the setup and tear down function for that, and I will show you how that works in a minute. I found a relatively straightforward piece of code in the T product class we wrote in the system, and it's the procedure set product. You can give a code to it, and then it will get the product from the database. And if it doesn't exist, it will raise a product not defined exception. So what I test here is querying to the database for a product. If not, it will raise the product not defined exception. So that's my first test. I create a class, set a product GTK demo, which is not in the database, I'm sure about it. And I test if it will raise a product not defined exception. The next test I created was the other way around. So it's not only getting to the database, but also inserting. So I create a product class as well, and call the new product procedure, which cleans everything up. Add some information about the product and executes the right properties to tables procedure, which is writing to the database. To test it, I create another um, instance of my tProduct class called the setProduct procedure we already saw. And if that doesn't raise the eProduct not defined exception, test product will contain the GDK demo product, but now loaded from the database. So test product is another instance as product. Product is the created one, the new one, and the test product is the loaded one from the database so that I can just compare, for example, the descriptions. But the main test is that it will not raise the eProduct not defined exception, which could be a test as well, but I now choose to compare the descriptions. But then, it comes to the setup procedure because, as you see, there are special attributes for the setup and teardown procedure. And in the setup, I start a transaction on the connection, and in the teardown, I do the rollback because, one of my tests is that TDK demo product not exists in the database and will raise an exception. So that should be working even when I add a product and create product. So that's where the start transaction and rollback should be configured. So when I run the tests, you will see it passed. And when I run it again, you see it passed again as well. In the next step, I want to show you how you can use the refactor method extract to class to refactor existing code from a form to a separate class. Because very often we have logic in forms and we want to use that again. So first you write a failing test for your new class structure, and you only write the structure, the new class, and maybe an interface to make the test compile. So here you see an authorization form. It is asking if the user has, for a user which has authorization to do a task, depends on the DM backend query authorized users. So I wrote a new class with a function to check is it an authorized user. Just added a raise e not implemented so that I know the test will fail. So when we go to the tests, you see I added a test procedure with also a setup, start transaction, and a function to add a authorized user, a GDK demo user, which is surely not in the database with all the authorizations on true. And this procedure calling at the start of my test, and I just start to check is this an authorized user or not. And I expect this to fail this test because I've not implemented it. But once I implemented it, I expect that this authorized is true. So when I run it, you will see the not implemented message. Next step is to implement the solution in our new class and get it working so that our test will pass. And after that, when our tests pass, we refactor the code in the form to the new solution. And when we implement, we try to move the code as much as possible the same as it is to our new solution. Like we did here, we copied the code from the form to the get authorized user function. I removed, of course, the control things like control.text through username and password. And I added the query as a dependency for the class to work because it depends on the authorized users query. So I put it in a class variable and I'm just using the class variable as the data set and in the same way it already did. So when I go back to the form, you see already the implementation here from the new class using the authorized users query as well here and just putting in the text from the edits. So I changed my test as well a little bit to give the DM backend query authorized users to my class as well. And another thing I changed was it will not result in a Boolean, but in a user ID because that was the case in the current situation. So I ran the tests. They are passing as well. Another test I added was a slightly different change on the code I did as well. In the next step, of course, it will raise an exception when it's not found. So not returning -1, but just raising an exception. So it was a new situation. So I added a test for a non-existing user raising an exception. Now we have our test passing. We can do the next step because we can improve the code. So it's now using a data set from a data module, which I want to change so that it uses only the connection and an internal query. So here you see my code again, and you see that I changed the query to the TFD connection, and that I implemented a query to get the user by username and password. So nothing changed on my test, only my implementation changes. So if my test is running, everything is okay. So let's see. So the tests are passing, so everything is right there, isn't it? But no, I assumed that the query would be the same as in the defined in the DM backend design time, but that wasn't the case. The form authorization was changing the query so that it's not the same as in the DM backend. And that's what very often happens in database applications, legacy database applications, that states and content of queries will change during the runtime of the code. So that you can't assume it's the same as defined on the data module every time. When I go to the form authorization and I search for the form show event, you can see a get authorized users function. And this is looking for the users only able to do this authorization type. So it's changing the query in query authorized users and have a different content than I assumed it should have. I've added this example to show you how easily you get into this trap, because these kind of constructions are very normal in legacy applications. So you assume that your test is also okay, because of course my test was not written fully correctly. Testing, is this user also authorized for this specific authorization type? But still, yeah, you easily think you're testing the right things, but it's not the case. So watch yourself for states of data modules, changing the data, etc., which makes it very hard to refactor code from a form or from a tightly coupled piece of code. So therefore, the next step I want to show you is how to test the form logic as well. I have another example for you to show how you can test the form logic. And now we write a passing test first, and we use the components from the form like a user does to ensure we have the same behavior we are testing. I've opened the main form of the application, and this is a search button. You can search in several ways for a customer. So you can search by ID, by name, by contact, and specific filters. And I want to refactor the search by name into a separate class so that I can use it anywhere else. So you see, this is the classic way, defining a lot of queries for specific searches. And at the end, it says, okay, if the record count of my data set is 0, then I have to ask, uh, should I add the new customer? So that is something you don't want in your unit test, because you can't deal with messages. When we go to the test I've created for this form, you see the search by name for non-existing customer. I just use the controls on the form as a user would fill in, and I just do the button click to execute the search function, which will not work at the moment because it will raise some form dialog. I just created the form in the setup, just a normal way, and the JDown frees the form as well to avoid memory leaks. So I want to show you how this looks like when I run it, because then you see how the message is popping up, and that you don't want that, because then you can't run it command line or in an automated setup as well. Then you see the not found at message. So how to get rid of that user interaction in a proper way without breaking the behavior of the code. Therefore, we refactor the code into the form itself, changing as less as possible, but we move out the code before the user interaction comes so that we can isolate the real search function. Now you see the same code from the search button, but only in the lines between the DM customers queue customer find and the record count is 0. You see the search customer function implemented, and I just only copied the code from that place to a separate procedure and just passing in the variables already defined in this procedure before. So it's just the same, exactly the same piece of code. So yeah, when you go to the search customer function, then here you see exactly the same code copied with the variables as parameters. So doing it this way, nothing really has changed. Only my test, of course, I changed my test to test this search customer function instead of clicking on the button, because that's not necessary anymore. So here you see I'm now calling the search customer function with only the search by name parameter filled. And I just test the same test as where I moved out the code, just to test is the record count here 0 or not, because it's a non-existing customer. Let's see if the test will run and pass, because I'm now using the existing code base to search for a customer, and it will pass, so I can move on with the next step. I now only had one test to test if a non-existing customer is not found, but of course there are more tests to cover the situation, especially to search by name for the customer. So I add first the tests I need to cover my code I want to refactor. I let them pass in the existing code in the form. So I will now add some more tests. So you see I've got 2 extra tests, not only non-existing customer I already had, but also a search by name for an existing customer. And I saw there were wildcards in the code, so I searched by name for a multiple customers result. So I defined 2 demo customers for it, and sometimes I use no customers, sometimes 1, sometimes 2. So yeah, the first is it's the same as we already saw. Then we search for an existing customer. I add 1 customer to the database. I search exactly for the name, and I find I expect to find 1 customer. And then I add 2 customers to the database to search for multiple customers. Do the search function with a part of the name, and I assume I will find 2 customers as well. Then I run the tests and see if they pass on the existing code in the form, and they will. At this point, we are sure the existing code is covered. Tests are running, so once I start refactoring and moving out pieces to a new class or new structure, I can test if the form logic will work as it did before. So now I can create a new class for the code I want to have, add unit test also for this class to test this class, move code or refactor code. I can do everything, and both tests for the unit, new class, and the form should be running as well. Here you see the new class I wrote to search for customers. I used the Fluent interface to add a query to it, and I used the guard pattern to check in my search function if I've got a query or not. As implementation, I copied the query from the original code. I put it into a constant, and I changed a little bit the wildcards and the string concatenation into a parameter, a query parameter. So I think that's better for the performance and structure of the code as well. So yeah, I copied some things into constants here because I want to have the same fields definition as used in the form. So it's now on one place, and you will see in a minute that it's used in the form as well. So in the customer query is also directly copied from the original form. So, and here you have the search test for my search classes, using the same kind of tests as the form is using. So you see exactly here the same testing for a non-existing customer, checking the record count, testing for multiple customers. You only see I've written a helper class to add the customer because on both unit tests I want to add a customer, which is exactly the same, of course. When we go to the form, you see I'm using the constants and I'm using the customer's search implementation as well now to search by name. So you see how it works with the Fluent interface. And I just replace this part of the code. So when I go back to my unit tests, this should work as well. So I'm now running my unit test, and now you see the advantage as well to have both tested. Even when the class is changing, my form should work in the same way I expected earlier. So all the tests are running and all the tests are passing as well. So these are the steps you have to take when you want to make your database legacy application testable. I think this is the most important part to start with. So I would say, please do it. Start and discover how easy it is to do unit tests, how it helps you, how it gives you more assurance that your code is working, and all the advantages we talked about in the first part. So I've got a little bit extra left. I will go quickly through mocking. That's very useful when you work with dependencies and especially interfaces, but what we discussed before is the most important part to start with. Sometimes your code has dependencies, working with other classes or interfaces, and when you write a unit test you want to skip that behavior so that you can focus on just what you're working on. In that case you can use mocks. So mocks are a kind of fake implementations of the interface of class you're using. In our application we've got a class using the VAT provider as a dependency. So I've got an example made from a unit test mocking this VAT provider, and I use Spring 4D mocking because we use the Spring 4D framework a lot, but Delphi mocks is also an available library to use for mocking. So the first thing we are gonna do is set up the mock to ensure the provider does what I want into the test. So let's go to the code, and here you have the T-transaction class within the constructor, the VAT rate provider, which is an interface, so I can easily mock that interface and give it the behavior I want instead of using the implementation. So when we go to the tests now, you see I've got a few tests defined with test cases to calculate the transaction. So as you can see as well, I'm using an enumeration here, which DUnitX also can translate to a proper parameter. So I've defined a few cases, and then you see in the setup that I defined a transaction using the VAT mock. So the constructor will recognize it as a VAT rate provider, but it is under the hood a mock, which is not a real implementation, but a fake implementation of the VAT rate provider I can use in my test as well. The first line in my test is setting up the mock, how to react on certain things. So here you see, okay, returns the VAT rate when the getRateByType function is executed with tvat type t1, which I always use in this test. So once the interface is passed with this function and with this parameter, it will return the given VAT rate. So here you see how the VAT rate provider is used. So once this line in the code is passing with the VAT type T1, it will return the VAT rate into F VAT rate with the one I've given in my test. So now I can execute the calculate function of the F transaction I created, and I expect the VAT mock working, but I also can test that, of course, after I called the calculate function, you see the line the VAT mock received, so you can check if the get rate by type is executed and how many times with the given parameter. So that's an extra check you can do in your unit tests to see if your interface and your dependency is used as well. So and after that I just get some prices from the transaction result and do the search to make my unit test working as well. So that's an easy way to get rid of dependencies when you don't need them for your test. So let's see if this test will run as well, and check my calculations with my VAT mocking provider. So I'm now running the tests, and surprisingly they will pass. It was a little bit extra to show you how mocking works. That was it. Hopefully you enjoyed the video and you can use it in your daily work. So I want to encourage you again to start with building unit tests and to work with it, because I'm really convinced you will enjoy it. Good luck.